Hey guys! In this video we would learn how to balance chemical equations. Now first let's understand what do we mean by balancing chemical equations. Balancing chemical equations means making the left and the right side elements equal. Let's understand this with an example. Let's say we're given this first question where iron 3 oxide reacts with carbon monoxide to give carbon dioxide and iron. So iron 3 oxide reacts with carbon monoxide. These are going to be our reactants. To give means it's going to produce carbon dioxide and iron. Now first of all, let's turn this word form to molecular form of compounds. So iron 3 oxide means we have iron, which is Fe. 3 means we're going to take the 3 positive charge of iron. Oxide is O with 2 negative. When we crisscross, we get Fe2O3. So iron 3 oxide is Fe2O3. Reacts with carbon monoxide. Carbon monoxide is a molecular compound, so we just have to go by the name. We do not have to do any crisscrossing. Carbon means single carbon. Monooxide means one oxygen. So these two will form the reactants. Now let's find out what are the products. Carbon dioxide, that is carbon with 2 oxygens. Carbon is 1, di means 2, oxide, and iron. Iron just by itself is Fe. Now reactants react together. So how do we show the reaction? Fe2O3 reacts with carbon monoxide to give the products as carbon dioxide and iron. Our goal is to make the iron atom on the left side equal to the number of iron atoms on the right side. Number of oxygen atoms on the left side equal to the number of oxygen atoms on the right side. Number of carbon atoms on the left side equal to number of carbon atoms on the right side. When all of these atoms are equal on the left and the right side, then we call that the equation is balanced. So let's make 2 columns. This side we would be putting the reactant elements, and this side we would be putting is the product elements. So what are the reactant elements? We have iron. How many irons do we have is 2. How many irons do we have here is 1. We have carbon. In total is 1 carbon on the left side, and the number of carbons on the right side is 1 again. Oxygen on the left side is at 2 places. One is with iron oxide and one is with carbon monoxide. So iron oxide has 3 oxygens, carbon monoxide has 1 oxygen. All in all, we have 4 oxygens. Oxygen on the right side is just present with 1 compound, and that is with carbon dioxide, and that is number 2. Now, whenever we are balancing equations, there is a very simple rule towards balancing is that we always balance oxygen and hydrogen elements at the end. So this is just a note. It will make life easier when balancing equations. We have to balance hydrogen and oxygen at the end when everything else is balanced. So let's see how this works. We would see our iron is not balanced. Now I want the right side to contain 2 iron. So I would just multiply the right side with 2. And this will give me 2 irons. How do I place it when I'm putting the numbers with my elements or with my compounds? The only spot where I can put the numbers is in front of the element or the compound. So I put 2 in front of iron, and with this I see my iron is balanced. Next is I balance my carbon, and I see my carbon is already balanced as both the carbons are 1 and 1. Now I would try to balance my oxygens. I see I have 4 oxygens here and I have 2 oxygens here. So the only way I can make my oxygens balanced is I raise this oxygen from 2 to 4. For that, I would have to multiply it by 2. So if I have to multiply this by 2, I would see this oxygen is contained in carbon dioxide, and the only spot where I can put a 2 is in front of the whole compound. There is nowhere else where we can put the numbers when we are balancing. Now with this, my oxygen becomes a 4. So my oxygens are now balanced, but I would see that my carbon becomes a 2. If I want to balance my carbon, I would have to put a number 2 here, and that would make my carbon to be 2. But with that, my oxygen again gets raised because my oxygen is no longer 1 here, my oxygen becomes a 2. So I would have 3 plus 2, 5. So I see here that 2 does not work. Now the next number I can multiply this 2 with is a 3. So let's try with a 3. 2 times 3 is a 6. If I do that, then here in place of 2, I would have to place a 3. With that, my oxygen becomes a 6, so no longer a 4. My carbon becomes a 3, no longer a 2. Here, if I want to make my carbon a 3, I would put a 3 here. And now when I check, I have 3 oxygens. I have 3 oxygens here untouched. So 3 plus 3 is altogether 6 oxygens. Now when I finally compare, I would see that I have 2 irons left, 2 irons on the right side, 3 carbons on the left side, 3 carbons on the right side, 6 oxygens on the left side and 6 oxygens on the right side. So this is the procedure that we use to balance equations. Sometimes the atoms have to be worked more than once in order to have them balanced in an equation, but sometimes only the first trial gives us the right answer. Let's say we have another question like this. Zinc reacts completely with hydrochloric acid to produce zinc chloride in hydrogen gas. So we need to react zinc with hydrochloric acid to produce. When they say to give to produce, that means after that is the right side or the product side, zinc chloride and hydrogen gas. So we would write our reactants, and the reactants are zinc is just by itself, so Zn, plus hydrochloric acid. We know hydrochloric acid is HCl, gives us zinc chloride. Now how do we form zinc chloride? We know this is an ionic compound. An ionic compound is formed by crisscrossing. Zinc charge is 2 positive, chlorine charge is 1 negative. Crisscross, we get ZnCl2. So when we react it, we would get ZnCl2 plus hydrogen gas. Another note we have to keep in mind is that if any element reacts to this category, it's called Hofbrinkel, in a reaction will be present as a diatomic molecule. So if they say hydrogen gas, oxygen gas, chlorine, bromine, iodine, nitrogen, or chlorine, we would never put them as is. Like zinc is put in as Zn. Hydrogen will not be put in as just H. It will be put in as a diatomic molecule, and that is H2. Now let's balance this equation. So how many Zns we have is 1. How many Zn here we have is 1. How many H here we have is 1. How many H here we have is 2. How many Cl we have here is 1, and how many Cl we have here is 2 again. As we always have to balance hydrogen and oxygen elements at the end, we would first look at zinc. My zinc is already balanced, so I don't have to touch this at all. Then I do not have to see hydrogen. I would look at chlorine first. So chlorine is 2 and chlorine is 1 here. If this side chlorine is 2 and I want to make it 2 here, so the only spot I can put 2 is right in front of the whole compound that contains chlorine. And with that, what happens? My chlorine becomes 2 on the left side. As soon as my chlorine becomes 2, my hydrogen also becomes 2. Because whenever we put a number in front of the compound, it changes the elemental value for each element in that compound. So if H was 1 earlier, it is now a 2. I have both hydrogens as 2. I have both chlorines as 2. I have both zincs as 1. So finally I got my balanced equation.